So who remembers how to start this problem from yesterday?
I got you.
Okay, how do we start it?
You want to move 2 to the other side.
Move 2 to the other side.
And then put a factor of times.
Okay, kids, I'm talking now. I must be the center of attention. Here we go. So we're going to move the 2 over here. Okay, now what?
You want to times the -2 by x minus 4 over x minus 4.
We want to get a common denominator so that we can combine those 2 fractions, right?
Yeah.
Okay. So if we multiply this by x minus 4 over x minus 4,
You can put it all
we're
over
going to
x
have
minus 4.
one big fraction. And on the top, we'll have our x plus 3.
Minus 2x
Minus
8. Or plus 8.
Okay. If you want to do that all right now, you can, but be very, very careful. That's going to be minus 2x plus 8. Everybody see that? Minus 2x plus 8.
I know it doesn't matter right now because it's a 0, but if that was not a 0, would you still multiply the x plus 4 on the other side of the inequality?
Okay, tell me again now what the question is.
Do you still multiply the x minus 4 to the 0?
No. No. This is an inequality. We aren't multiplying through by anything. What I'm doing here is multiplying by 1. I'm getting a common denominator.
Oh, okay.
It doesn't have anything to do with what's on the other side.
Okay, and then you're going to want to factor that down. That's
Just
the answer.
Just collect like terms.
Yeah, and you got to graph that.
Now we're going to go to the number line. And we're going to put a couple of dots on the number line.
11 or negative 11. Positive 11 and 4.
Now, where are those numbers coming from? Let's make very sure you know why you put, he's right, those are the numbers that go on the number line. Why did he put those numbers on the number line? What does 4 do to the denominator? Makes it 0. What does 11 do to the numerator? So where do the dots go? At whatever makes the denominator and the numerator 0. That's where the dots go. Now, tricky piece. Little bit of a tricky thing here. You see that symbol, and you think I'm going to color in those dots, because that's what we do when we see that symbol, right? But that one doesn't get colored in. Only the 11 gets colored in. Can somebody tell me why, even though there's an or equal to, I'm not coloring in the 4? It can't be 0 in the bottom. X can't be 4. That rule kind of supersedes everything. You can never have a 0 in the denominator. So that denominator dot, the dot that comes out of the denominator, is going to be open, always. Okay? Now, I think this is as far as we got yesterday. Do you have a thought on what we might do next?
Shade.
We're going to shade somewhere. And what we're going to do is exactly what we did before. Pick any number you want except a dot. 3. So 3 is right here. Keep in mind, what does this mean? Well, less than 0 means what? Negative. So this fraction needs to be negative. If you put in 3, your top would be positive, and your bottom would be negative. Does that give you the kind of fraction that you wanted? Yes. So we color that in. And then just like before, if this section is colored, this one isn't, and this one is. It's just like before. Remember when we did that before? And then our answer is x is less than 4 or greater than or equal to 11.
I'm still a little confused on why you color in one of the circles and not the other.
Because x can equal 11, because that would make the fraction 0, if you're allowed to equal 0. What happens to this fraction if I put 4 in here, Robert?
0.
Am I allowed to have a 0?
No.
No, that's why that one can't be colored in.
Okay.
All right, there are a couple from tonight's homework. We're going to do some more of those because they get a little bit tougher than this. So we wanna do some harder ones. But first, I wanna make sure you're okay with some of the things I asked you to do in tonight's homework. It's very simple. Some of these problems you have already done before. But I want you to look on page 264 at problem number 3. The directions are different. You know what to do, it's just that the problem's never been presented this way before. So problem number 3 looks like this. Now, what do the directions say? So this thing could equal 0. Now that's easy. I don't know what order they go in, so I'm not going to do that. I'll say equal 0. What values are going to make this thing actually equal 0?
-7.
-7.
-4.
-4.
36.
And 6. Those are the dots, kids. If you were going to do this problem, those would be the dots you put on the number line. Would you agree with me?
Yeah.
Those are the numbers that would make this thing equal 0 if you plugged it in and multiplied out. If you put in -7, that's going to equal 0. If you put in -4, it's going to equal 0. Just like over here. Why did you put these dots here? Because that's where you got 0, in the numerator and the denominator. Well, here's where we get 0 in each piece of the problem. Okay. Now, let's look at this number line. Let's pick a number like 0. I'm going to pick 0. 0's right in here. What happens to this guy if I put in a 0? Well, let's see. That would be positive. That would be positive, and that would be positive. Would you agree with me? So this section of the number line would end up positive if I put in a number in this section. Now, you see that right there? That's a game changer. So I'm not going to be able to do my alternating thing. I'm going to have to check each section, okay? So I'm going to check this section. I'm going to put in 7. 7 would make me positive, positive, positive. So this section would also be positive. Would you agree with me? All right, now I'll put in -6. -6 would make me positive, negative. Now watch it here. This is still going to be positive because you're squaring it. So what's that turn out to be?
Negative.
That's a negative section.
So the other side's good.
-8 would be negative, negative, positive. That's a positive section. So when the directions say, where does this equal 0? The dots. All right, where is it greater than 0? Well, it's greater than 0 in this section, or in this section. Would you agree with me? See what I'm doing? And then where is it less than 0? Where is it negative? Only between -7 and -4. That's the only section that came out negative. So what that section of problems is asking you to do is simply figure out everything that's positive or negative and then make a list of it.
I don't understand why that, like, one section's negative and the last one's not.
Well, I put in, I can't remember what I put in, but let's say we put in -8.
You did.
That would make this negative. It would make this negative. And it would make this positive. What happens when I multiply a negative times a negative times a positive? Yeah, I mean, it just is positive. Okay? Again, most of your problems you're going to be able to do the alternating thing, so you're not going to have to physically check each section. But because of this, I had to do my checking. If there's anything odd about the problem, check every section, okay? All right, now I want to look at number 17. Because we have been doing all of our problems what we call algebraically with a sign chart. problems graphically. So get your calculators out, if you would. And put this thing in and graph it. Obviously, you're not graphing this part because you're putting y equals. There's a section of problems tonight that say solve graphically. This is what you're going to do. I got something that looked like this. Did you?
Yeah, you could have fixed Y.
Now, you want to somehow use this graph to solve this problem. Well, what does this mean? Greater than or equal to 0. What does that mean? Positive. So where on the graph do you have positive y values?
Where it crosses the
From
line.
here on, right? So first thing you need to do is identify that point, right? We know how to do that, right? Okay, so let's find that point. I got about negative 1.15. Can somebody confirm that?
Yep.
Now this is an or equal to problem, so that means that's going to be included. And what are you going to say? What's your answer?
X is greater than.
X is greater than or equal to negative 1.15. Now, on some of these problems,
It'll be more than one.
yeah, when you graph it, you've seen this before, it might look like this, right? So if that were a greater than problem, you would need to look at this section right here. And then again, this section right here, right? So it's possible you're gonna have two groups of answers here.
So like on like a one where like this like it has 3, would the first 2 be like bracketed off and like its own separate, and then like the next one would be okay.
Say this or this.
Okay.
Could we graph the first one that we did too? Find those answers?
You absolutely could graph that. Now, here's the thing. I don't want you to get over-reliant on the calculator because you're going to have to be able to do this without a calculator. So I want you to be comfortable with the number line called the sign chart. I want you to be comfortable with that. But all of these can be done with the calculator. Okay? All right. Well, I'm going to do one more of these rational ones. And then, I don't know, we'll be close to being done. Before I do another rational one, was there anything from last night's homework that confused you? Is there any of the equations that we needed to look at? Reagan?
Number 27.
All right, this will be a good review for us. Number 27. I'm going to go ahead, Reagan, when I copy the problem, I'm going to factor that denominator. Okay, that would be my first step. Okay, what did you do?
I realized what I did wrong, but what you're going to do is you're going to multiply each of the numerators by x plus 4 and x minus 1.
Yep, you sure are. Everybody pay attention, especially if you had any issues with these problems, because this one's no different than the other ones. I mean, it's just different numbers, but this is our strategy. And why did we do that, Reagan?
To cancel out your
Yep.
denominators.
So we are left with 4x, x minus 1. Gotta get a darker marker. Plus 5 times x plus 4 equal 15. So 4x squared minus 4x. So we have a handy dandy little quadratic. 4x squared plus x
Minus 5, or plus 5.
plus 5 plus 5?
So, alright.
Shooty tooty.
You can do borrow and pay back.
That's not gonna factor.
No,
No. Can you subtract the 13 over and then prove it, or no?
What do you mean? So make this a 5 or leave it 20 minus 15?
Make it 20, or,
triple now.
no, make it minus. Just,
Yeah, that doesn't factor. So x equals negative b plus or minus the square root of b squared minus 4ac. Oh boy. What's gonna happen? We're gonna get no real solutions for sure. What is that? The square root of what? So we didn't get any real solutions, but we got a couple of imaginary solutions. Vocabulary from yesterday, excluded values. What are excluded values?
Negative 4,
Negative
1.
4 and 1. We didn't have to worry about that, but. Lily?
number 19.
Okay, one more here, and then we're gonna jump into our inequality. Number 19. Okay, Lily, where am I crossing the x-axis in that picture? Yep. Am I crossing anywhere else? So there's one answer to the problem, and it is negative 5. So anything else that's listed as a potential answer can't be an answer, because it's not an x-intercept. Remember, your solutions are going to be x-intercepts. Okay? This one, if we graphed this one, it would have no x-intercepts, because the only solutions to this equation are imaginary. All right. Now I want to try another one of these rational equations. Little bit bigger, but we're not scared of it, because we're going to do it exactly the same way we did the other ones, which is what? Step 1.
Subtract it over.
Subtract it over. Now hopefully you're already thinking about step 2.
Times this side by x minus.
You got two fractions here, and you want to subtract them. So what do you have to do when you subtract fractions? Get a common denominator. So this time, we're going to have to do both fractions. This one's going to need an x plus 7. And this one's going to need an x minus 3.
How come we can't multiply each side by x minus 3 and x plus 7 and cancel the denominator?
Okay, we talked about this yesterday. Can someone explain to Vincent and anybody else that has this question, why don't I just do what I did here? This made it so much easier, just getting rid of all those fractions. Why can't I do that, Lily?
Because it's an inequality and you don't know what x is and it could be.
Remember that from yesterday, Vincent?
Oh, yeah.
When I multiply in an inequality, I gotta know if I'm multiplying by a positive or a negative because I have to know what to do with that sign.
Okay.
When x's are involved, I don't know if it's positive or negative. You understand?
Yeah.
Yeah. We wish we could do that, but we can't. So here's my common denominator. All right, here we go. What have we got here? X squared plus x plus 7x plus 7.
Plus 8.
Now here, now watch it.
Did you do anything with that negative?
This is just this one. I've done this one now. So I have this one. Now I'm going to subtract this one. So this is going to be x squared minus 3x minus 4x plus 12. Does everybody follow that? It's a lot of writing, but it's pretty easy. We're just boiling each fraction. All right, so we've got x squared plus 8x plus 7. All right, now minus x squared plus 7x minus 12. This makes a negative 7x, so it becomes plus 7x. All right, so what do we got up there on top? 15x minus 5.
Did you get 5 out of that?
Do you foil the bottom?
Do not FOIL the bottom.
I don't know.
The only reason I FOILed the top is I had to collect like terms.
Would you want to take the 5 out of the top to?
You can, there's no need to, but I mean, it wouldn't hurt anything if you wanted to do that. What we're gonna do now is go to the number line, and this time there's going to be 3 dots, people. You understand why there's 3 dots? There's a number that makes the top positive, or excuse me, makes the top 0. What makes the top 0? What number would we put in here that would make that 0? 1/3? Now, again, I don't want anybody messing around struggling with that. Just set it equal to 0 and solve it. Some of you can see that right off the bat, some of you can't, so just write it down, solve it. So we got 1/3. What do we get here? Negative 7 and 3. So they gotta go in order, so make sure you put them on there in order.
You only shade the middle one?
The only one that's gonna get an or equal to, yes, Dan, is the 1/3. Nothing odd about this problem, no squares, so I will need to check one number. So pick a number, 0. If I, and 0 is right in here, so I'm checking this area, 0. The top would be negative. This would be positive, and this would be negative. So that section turns out to be positive, right? Negative over positive, negative. What do I want my fraction to be? Positive. So that works. This doesn't, that doesn't, this does. So your answer is everything between negative 7 and 1/3, or everything bigger than 3. These problems are perfect for your interval notation, so if you want to use that to keep in practice for next year, that would be great. That would be your interval notation. education. Okay, everybody good? All right, go ahead and start your homework. And tomorrow we'll finish up our hard inequalities and move on to the next thing.